Hello, everybody. Thank you for having me. I'm Derek. I'm the tech lead at Doctors Without Borders, and I want to show you a little bit about what we do as a team, what we're working on. But maybe just as a beginning question to understand the room, who is working on RAG applications in their company? Do you guys know what RAG is? That's great. Do you guys use Copilot 365? Are you guys happy with it when it's integrated into SharePoint? Yeah. Well, I'm not. That's kind of why we started working on this, because we really wanted to improve the access to information. And today I'm going to talk to you about why I'm doing this and why we just started a new team. So, just to give you a bit of an understanding of how big MSF is quite big. We do about 16 million consultations each year. We treat about close to 3.7 million malaria cases. We vaccine almost 3.3 million people on measles. We have a total budget of about 2 billion in private donations. And what I'm really proud of is that 80% of them come from private donors like yourselves, maybe. And this also led us to be really independent and not rely on government funding. We use very little for management fees, one of the lowest from all NGOs. And most 80% goes to actually the social mission. We have about 70,000 people employed as well, just to show you the size of the organization. It's not a small organization. What do we do? Well, we have about 25,000 doctors across the world in about 70 different countries. We develop complete hospitals, wash units for water sanitation, massive operations. We also have a massive department on humanitarian affairs that focuses on advocacy. Well, when you hear these things, you already hear, wow, that must be a crazy amount of data. And yes, it is a data engineer's dream to work in an organization like myself, I must admit. And we have many support departments. We have logistics, of course, and we have a whole procurement room unit in Schiphol, a whole warehouse that is completely packed. We send millions of medicines across the world. HR, we need to employ people all over the world, both locally and in our headquarters. ICT, we need to be available in so many different countries across the world. We need to keep up with innovation. Finance, we need to send money across the world, fund projects, work with different local governments. Of course, fundraising, a massive part of our organization to get fundraising and to get the money to do what we need to do. And of course, project management office. And we kind of call these within our organization the core and the support activities. And as you can imagine, I lie in that ICT domain somewhere. So how does that structure actually work? Well, you must have heard of Arts zonder Grenzen, the Dutch variants. Well, we actually have partner sections and branch offices across the world, and they are responsible for raising funds that eventually go to these 6 operational centers that you see here. I work obviously in the operational center of Amsterdam, but the way you have to see this is that each operational center acts as an independent unit. And the reason why is this is the case is because decentralization allows us to act a lot more quicker. So for example, OCA represents specific countries, OCB represents other specific countries and missions, and eventually we serve over 75 country programs across the world. As you can see, this is quite a spider web of organizations and stakeholders, and also quite a siloed approach, which obviously has its pros when it comes to doing operations and being to missions and war zones as quickly as possible, but cons when it comes to serving IT and needs, because all these different OCs have their own IT departments and teams that have different ways of working. I started working at MSF 2.5 years ago. The first 2 years I spent bringing their whole data platform to the cloud. And in the last 8 months, I started becoming the tech lead of OCA's AI department. I just hired 3 people. We're a very small team, but what we focus on is automation. So automating repetitive tasks by using generative AI or other basic if-else logic, if that's easier. We provide insights, so we do a lot of data engineering. We provide access to tools like Azure AI Foundry. I'm also going to show you some of the tools today. We build a lot of templates. So we have our own GitHub organization where we wear templates so that other OCs can also use our repositories and deploy our solutions. We started to keep it as small as possible. So we focus on Azure, we focus on Terraform, and we focus it on Python. The more languages, the more technology stacks, the more complicated it gets. And also, we're with 4 people. Again, what we are really focusing on is collaboration. So we want to make these templated repos that anyone can use. Particularly, they're closed source. Some are open source for the wider community, but the majority is closed source within our organization, so people can quickly deploy the same solutions that you're about to see. Another big thing that we do is obviously governance and training. So we create governance policies on fair use of AI, but we also do training. So we teach people in IT departments how to use Terraform. We teach people how to run things on the cloud. We teach people how to use Azure AI Foundry. But we also teach people how to write a prompt in a window. What are our principles? Well, when I started this team about 6-7 months ago, I wanted to make sure that we at least have some of the design principles so that we can keep it in control and not make things more convoluted than they need to be. So as a team with the 4 of us, we decided on these principles. One is designing for failure. Everything is infrastructure as code and DevOps. If one of us leaves the organization, which tends to happen quite a lot, the average tenure is about 3 years, we want to make sure that the next person can pick it up and deploy it again. Another one is security by design. What I find really important is build for scalability, flexibility, reuse, and redundancy. So coming back to infrastructure as code, DevOps, cloud, these type of principles. Another one that I find really important is in our team, you build it, you run it. Well, that's kind of the definition of DevOps, I guess. And another one that I find something that we need to do a little bit more is design for evolution. I think a lot of organizations are vendor locking themselves in Microsoft, and America scares me right now. So I'm going to show you 2 concrete examples. First one is the actual AI platform. So this is the first solution I built with a colleague in the US. Basically what we built is ai.msf.org. It's the AI portal for MSF. Why did we do it? Well, it's cheap. We only pay per tokens, right? So we have all the newest models, but we don't have to pay licensing fees of 20 euros per person. Well, imagine 69,000 people, that gets really expensive. It's model agnostic. We can just add whatever GPT model or any other AI Foundry model that is available. It's extensible, so we're adding a lot of new features like DALL-E, speech to text. It avoids vendor lock-in, that if we do want to have other API integrations with other LLMs or other services, we're not locked in. So how does that look like? Well, it's just your own model where you can select, you can create your own custom prompts. In chat, you can just open your own chat. It's basically ChatGPT. I would like to say that it's something more and more exciting, but it's basically what we're doing is just a front-end layer on top of all the different AI services within Azure. And we basically took this from an open source project and started extending it with our own integrations and features. I can recommend doing this if you're a large organization, simply because the total cost of this is about 600 euros per month, and about 300 people currently actively use it. So it's less than 50 cents per user, because the infrastructure cost, the web hosting, that's the more expensive, but the tokens are really cheap, right? Like, it's pretty difficult to spend $20 in tokens. And if you do, I'm pretty worried about your for loops. But what I really wanted to talk about and demo and walk through is the importance of RAG. RAG is Retrieval Augmented Generation. It's the ability to integrate your own knowledge bases with large language models. So an example that I'm going to show you are this chatbot that I made, and I hope no one is filming this because it's internal knowledge. Yep. So we have a thing. Nice next. Yeah. So we have these things called monthly medical reports. These are reports that are written across MSF. They're 10, 20, 30, 50, 60, 70, 80 pages long, and they're done for each mission that we're in. So we probably have a corpus of more than 4,000 documents of historical data. Well, if you try and put that into a Copilot agent, it's gonna fail. I can tell you that. So what we did is we built a RAG system, and I'm about to demo it. first thing we, of course, have is just a little intro page for people to just understand what kind of questions you can ask. I'm going to put this down. So one of the questions, for example, would be, tell me about mental health activities. Sorry, everyone here liked it. So what we can do is we can ask the LLM, we say, okay, what mission are you looking at? It says, Edward, tell me about mental health activities. Well, what it's going to do now, it's going to go to our vector database. It's going to take up information, and it's going to return chunks about what activities we did in MSF. Well, like if we go up here, it says a total of 119 mental health activities with a little reference, and you can open it up, and it will jump exactly to the page and document on SharePoint where it's found. So we build these large RAG systems, and we're doing this for every department that we see. They're telling us, hey, build a RAG. These are proof of concepts, and we hope to soon integrate them into ai.msf.org, where based on the role and position that you can have your own RAG chatbot. So if new employees come in, they can converse with their own internal knowledge bases. And what this actual presentation is about is how did we do this and how did we make it, and why do I think any company should be working on building RAG solutions? First of all, RAG is, if you do, I don't know if you guys tried, for example, just custom GPTs. They're immediately very limited on the amount of documents you have. RAGs are not. If you use SharePoint, it's not really relevant with the Copilot Studio. It's not really looking in the documents because it's not really using anything related to embeddings. So that's why RAG architecture is actually really, really important. And actually what I'm about to show you is what Microsoft actually recommended us, because we work with Tech for Social Impact through Microsoft, where we collaborate with other NGOs on tackling specific problems. But I'm just going to explain how we did this. So what is RAG? Well, what you do is you take a bunch of documents, right, and you encode them and you run them through an embedding model. So you turn words into numbers and you pump those words and numbers into a vector database. Basically, what you can then also do is you can have a query that also goes through an embedding model and then does a similarity search on this vector database to find the right words. Why is this important? It's because there's two types of searches that well, there's a lot more, but I'm going to keep it simple. We have keyword search and we have vector or semantic search. Keyword search is based on writing the right keyword. So let's say you look for malaria. No, malaria is a bad one. Let's say you're looking for cancer. This is a clear one. Cancer is actually, in the medical term, malignancy. If you then look for cancer in the documents and you only use keyword search like in SharePoint, it won't return anything. But if you do cancer, it will also return malignancy. And that's because of that embedding model, and that's what large language models are very good at. That's why that whole vector database and creating vector databases on your knowledge bases is extremely important. Basically, what it will do is it will encode your query. It will look into the vector database for specific terminology. It will return you data. It will pump that data into the large language model and will take a response. That's kind of what we just saw. We asked a question about, tell me mental health activities. It found all the mental health activities related. So you could also see that sometimes it wasn't mental health, but it was something else. It returns them all and then gives it a response. So what does this architecture look like for the more technical people? Well, we take information from documents. We take them from APIs. We ingest them through Databricks. What we're using here is particularly using cognitive intelligence services. So the one we use is document intelligence inside Azure. And I'm going to show you later why. What it does, it can turn these PDFs, PowerPoints, Word documents into Markdown, which is a specific file format that we can then parse and build these chunks and embeddings from. We ingest that, put that in a storage account, we create the embeddings, and then basically we pump that data into the cognitive service, and then we have a web app or another type of app that then talks to these models or these databases. And then we have container registry where we run our Streamlit apps. Maybe I'm running around too fast. Is this making sense? Or yeah, it reads left to right. Basically, long story short, is we're using a bunch of Azure services, the most important ones being AI search, just to store our embeddings. We're using document intelligence to convert these documents. We're using Databricks to run our ETL and data processes. and we're using all the other Azure services just to store our data or to store our web apps. So within our team, we actually kind of manage several repositories to do this. So the ones with a C are closed. The ones with an O are open, are available to you guys as well. So the most important thing that we have is our infrastructure, of course. So what we have is this repository called MSF Terraform modules. And inside here are all the module definitions to deploy an AI service. And then for each specific OC, we have a separate repository that pulls code from this repository to then deploy the whole infrastructure so that each OC can have similar infrastructure, but that they can manage it themselves without me needing access to their infrastructure. Then we have the MSF toolbox. So this one is open source. Basically what we're doing here is we built our own Python package where we built generic clients to source data. So what we do is we build a Python package to source data from SharePoint. We built a Python client to source data from a bunch of open source data file formats. Think about weather data, Modis, to ACLED, which is global event data. We basically build easy clients that anyone with basic Python skills within our organization can use to scrape data from different data sources. So if they don't use Databricks, but they might use some other ETL tool, they can still run our package and run our stuff. And then what we have is the RAG solution template, which is the actual data pipeline to do this. And that's what I'm going to demo today. So how do we actually turn this data into a vector database? And then in the front end, well, you saw ai.msf.org. This is also an open source repo if you want to build your own ChatGPT interface for your organization. There's a lot of different variants and flavors. I would recommend looking at this as an organization, particularly to not be vendor locked into a specific cloud provider. And then the last one we have is we have a bunch of templates, Streamlit web apps. I like Streamlit. I love Streamlit. And the reason why is because you can pump out a POC or a minimum viable product within a very short time frame without looking at very complex frameworks, because I'm not very good at JavaScript, but I can deploy a JavaScript web app, but that's almost about it. But with Python, I'm a lot easier to work with. So creating this RAG solution, that chatbot that you just saw, right? The one where we're allowed to interact with our internal knowledge base. How do we do that? Well, first is, of course, we define the Terraform infrastructure. So we have a dedicated solution repository. So here you're already seeing that this is, for example, a solution, and we're pulling from specific MSF Terraform modules to create our services. Everything is put into variables and configuration files so that any other OC or any other company can easily deploy them if they want to. And we have a dedicated solution repository for our RAG apps, for our AI web platform, etc. Then what we do is when we explain this pipeline to other OCs is we tell them that we have these two different repositories. We have choosing the solution. So we have one repository that is great for building RAG solutions for structured data. Well, structured data is anything that comes in a structure. And unstructured data, we have another repository, where we are converting openfold formats. So basically what they have in Azure Document Intelligence is that they can convert PowerPoints, Word documents, and PDFs to Markdown. So we created these two different repositories. Once you've determined whether your data is structured or you have unstructured data, what do you want to build a chatbot on? Then you start going on this cycle that we call. And I'm going to walk shortly through them. How much time do I have? Plenty of time. Okay, wow. I feel like I've been standing here ages. 18 minutes. Okay. So first we created an index, which I'm going to show you. 2 is we source the data, as you can imagine. Then we do a lot of data processing and post-processing to put it into the vector index. And eventually we load the data in. So first of all, we configure this thing called an index. An index is basically a database. So what we use is Azure AI Search, and we configure Azure AI Search by defining a schema. This is similar to defining a schema that you would do in a table in a database. We're defining a schema into a index within Azure AI Search. And basically what you do is you start defining the different field attributes. So for example, what's the field name, if it's URL, what kind of data type it is, what is the primary key. Then these are quite important. It's like, okay, is the data retrievable? Is the data searchable? This one becomes really important because filterable means whether you can actually filter dependent on the country that we're saying. So it really becomes important about managing your data structures so that you can make these fields and make the search the most relevant it can be. Sortable, and definitely last but not least, is that these little vector fields, basically what that means is you're taking specific content, you're running it through an embedding model, so you're returning it into an embedding model to then store it in this vector index. So I'm going to quickly show some code of how we're doing it, which might be difficult with a microphone in my hands. But the first step, right, to create this index, what we do is we configure fields and then we create or update this specific index. I hope that it's not too small. Let's pause it. The template button, this one. Okay. So what you can immediately see is that we are using document intelligence, using some key credentials. So what we tend to do is we load in these configuration files. So for example, this is IO Unidata. This is our logistics database. And what we're doing is we are creating a configuration where we're defining all these fields that I just spoke about, right? I'm defining whether the fields are filterable, sortable, searchable. I'm basically creating an empty table in a vector database or in a vector index. And that's what I'm doing here. I'm defining it based on a configuration file so that later if I have a different table or a different structure of a table, I can quickly create a configuration file and build these indexes for as many data sources as I can. So the one I've been looking at today lately is building a chatbot on all the USAID data entries that is on their website. So we scrape their data and then we can build a chatbot on the USAID. After that, you configure the fields. So basically we loop through that, we create a specific index, we return the field, and then eventually we use that to create or update the index. I feel like it's quite difficult to read this and go through this, but very logically saying, also in the sake of time, we're creating these indexes, we're creating these tables, and then we're putting them into the Azure AI Search Index so that later we can pump the data into them. And if you are really interested, please approach me. I can explain it in more depth at another point in time. What we then do is, well, this is what I just told you about earlier, is we source the data. So we need data to put into these tables, right? So what we built is the MSF toolbox, where we have a bunch of scrapers on different data sources that are interesting to us. Unidata, SharePoint, GDelt, Azure. They're clients with very good readmes, or at least I like to think very good readmes. Maybe sometimes they're missing, but this ensures that basically these data pipelines to source this data for these search indexes, that anyone in our movement can do it, even if I might leave the organization, or if somebody don't run Databricks and somebody's trying to run something else, or they just want to locally run it, so that people can source this data. Then this part. I'm going to show you a little bit how it looks in the back as well. But basically what is most important is that you have entries in your vector database, right? Just like you have rows in a table, you need entries in your vector database. So what you need to do is you need to convert all that data into new line delimited JSON objects, or what people often refer to as chunks. And these chunks require some processing. But the beauty about these chunks is you can also do metadata enrichment. So you can add these filterable fields. For example, I add country, for example, that I know that it's from Chad, and it makes sure that it looks only for filterable fields within Chad. But it also can be adding page numbers to the chunks. So you know how I clicked on that link and it immediately jumped to the right page in SharePoint? I add that to my chunk. But it also allows you to add many things to filter or actually make the RAG responses more accurate. So the way we do it is, well, we have structured data. We turn them into these JSON chunks. So for each data source, that is different, as you can imagine. But then I will quickly show you what we're doing here. We would normally take a PDF. we turn it into Markdown, and the Markdown we then also turn into JSON chunks. So how does that look? Well, I'm sure you guys have all seen a PDF before. But what we do is we turn those PDFs into Markdown. And why do we do this? Well, Markdown is really good at knowing and parsing information and seeing headers in specific text, but also being able to parse specific tables. So for example, if I'm looking for a specific date, if you put this chunk in an LLM, it knows exactly March, April, and then knows how to find that value in the table. That's why Markdown is very, very important in this setup. I'm sure there's other ways, but the LLM understands Markdown well. Once we have those Markdowns, what we do is we then start chunking that data. So we put them in these little JSON chunks. How does that look? Well, they become exactly like this. So we split these chunks on headers. So our logic is that every piece of content, right, when you're asking, hey, tell me about water sanitation, then it will look at the content water sanitation, but it needs to take that whole context, the text before and the text after, to put it in the LLM to summarize it. And then we also add this metadata enrichment, right? What I said earlier about focusing on country or focusing on period. We also add the source location of where it is in SharePoint so that we can, when you open the link, it jumps to the right page. So there's a lot of post-processing done in order to actually build a RAG system. So we have creating the index to build and store the data. We then have to source the data, and then we have to process the data. And then last but definitely not least, we have to load the data into the search index. So how do we do that? Well, after having processed the data into these new line delimited JSON objects that I showed you, we need to create these vector fields, right? These embedding models. So what it does, it turns, for example, that word into numbers. So that's what a vector database it stores, is those numbers. So I need to select the specific fields that need to become retrievable so that it doesn't only find cancer, but also finds malignancy on the content-defined objects within that field. So again, I wanted to show some code, but I can imagine that it's a bit convoluted. But basically what we do is we use this function called batch and upload documents, and I'll quickly run through that. So every time we have those JSON indexes, right? Okay, thank you. So we have the batch and upload documents. We actually just take the documents and we run a specific embedding model through it. So we have this embedding client that then turns each little field into these numbers. And eventually we then just batch upload it to the Azure Search Client, which is just a very simple function, but it's just taking the respective columns that we find interesting or searchable. We run them through an embedding models, and then we upload them and pump them into our vector search AI index. And then last but definitely not least in this process is, of course, building those data pipelines. So we use Databricks, so we just want to put them in order, right? So one would be run the Python script to create the index, has that JSON file change. Two is then convert those documents, right? We just said we need to convert those documents to Markdown, so all the documents are going to be converted to Markdown. Afterwards, we chunk these documents, right? We make them in these little JSON objects. And last but not least, we loop these index documents into our vector database. The beauty of this is that all of this, right, what I showed you earlier, is that it's all configuration driven, which means that we can have multiple different, yes, the wrong repo, sorry. We have a bunch of different chatbots where we can just say, where is the site and location on SharePoint that we need to index? So we can take whole folders on SharePoint, some that might be massive SOPs, hundreds and hundreds of documents. And all we do is we need to run these scripts, right? Create the index, ingest the SharePoint, convert the documents, chunk the documents. And basically what we can do is copy and paste this whole repository, We copy and paste the whole infrastructure, and in my opinion, within a couple of hours, you should be able to build your own RAG chatbot for your own OC. So to sum it up, we try to make these templated repositories for both infrastructure and our data pipelines that can be run in any type of environment, so people can build their own RAG chatbots in order to prove access to information. So this all sounds nice, but obviously we have some challenges as well. The biggest challenge that I have is understanding the operational complexity, right? We're such a big organization. What data is important? How is data organized? Where does the data lie? We're operating in 70 countries. Not everybody uses SharePoint. People have their documents in other places. How do we source that data? Another issue, as I showed earlier, is that siloed approach. This decentralized approach leads to faster operations, but it obviously leads to less synergy. So what we're continuously working on right now is how do we find these other OCs, show them our code, let them try out our code, and that they're not going to spend money to build the same type of solutions. The speed of innovation, IT, data, and AI is evolving so fast. We as an organization often don't know where to invest. I think the agentic wave, what was presented earlier, is an interesting way. We focused on RAG because we think access to information is the biggest problem. Because RAGs are also good at translating and using other languages because of these LLMs. Another one is this employee tenure. So that's why we think this RAG solution is very good. Average tenure is about 3 years, and we employ 70,000 people. Imagine having a new position, and you can immediately speak to a chatbot that says, okay, what are my guidelines as a logistics advisor? Where do I need to contact X, Y, and Z? So we're looking at building all these RAG chatbots for all these different departments by making scalable infrastructure, scalable data pipelines, etc. Another one is the diversity of skills. We have over hundreds of cultures in our organization with different domain backgrounds, logistics, ops, medical. They all have different priorities, which means it's difficult to navigate what is important, which data is important, what solutions should we build. We decided to focus on RAG because we think this one solution and this one problem is relevant regardless of what department you work in or regardless of what culture. The only constraint is you need access to a computer, which is obviously also a massive constraint within our organization. So my last slide is on the priorities that we've defined as a team. So we've decided as a team that we want to become a platform team. So we want to become a team that provides access to AI tools, so AI Foundry. So we're also giving people access to Azure AI Foundry to translate documents and to add tags so that we know and monitor the cost. That's actually our biggest work. But we also build these custom platforms like ai.msf.org, but we also build these data pipelines for custom RAG. So we really want to be the team that builds scalable solutions and code that other people can use. Another one is strategic direction. We really want to try and understand how AI can help our management team to achieve their goals. I think this is probably the most difficult one, simply because of the differing priorities. When you're going into a war zone, AI is probably not the first thing into mind. Another one is breaking these silos. So we really want to build these intersectional collaboration platforms. So what we set up in our team is a GitHub Enterprise account where everyone can come in and work together. And now we're creating these AI landing zones so that you can deploy your own Terraform infrastructure so that you can immediately set up your own AI resource hub project without needing our help. But the way we need to do that is by talking to the other IT departments in other OCs and navigating the politics around this. Another one is really building practical trainings. Like these RAG chatbots, it's great that we have them, but the majority of people still don't know how to write a good prompt. And how to actually understand how the system works and how to interact with the system, how to know what data is available in the system, having digital literacy skills. So what we've identified is that we need to have different trainings in our organization. We have the champions, so people who know how to program, have probably written an API request, know AI Foundry. We have the leaders, who are people who are really excited about AI and data within the departments, who we then enable them and give them access to the newest AI solutions in Azure. Then we have the users, who we just want to show, okay, how do you use ChatGPT? Please go to our platform because we use Azure OpenAI. It's secure. Don't use open source things. And then you have the absolute beginners who have no idea and they just need to have an understanding to become an average user. Last but definitely not least, is staying up to date and staying informed. I think this is the challenge of any AI team these days: is which model am I using, which technology am I using, which cloud provider am I using, which data storage solution. We're lucky that we have Microsoft, who is helping us with a lot of this thing, and we also had some pro bono support and partners who help us on developing specific machine learning algorithms or helping us understand some other complexities and how to implement maybe Copilot. So we have a vast network that can also help us stay informed. Thank you so much. Wow, I did that in time. I can imagine this was a lot, and yeah, thank you.